Describe how to write the equation of a line in sloppage-intercept form when you were given 2 points on the line. Here's what you will do whenever these happen. Okay? Let me be smaller first. You must find sloppage. Oh, I spelled that wrong. Sloppage first, then find the y-intercept, or simplify using point-slope form. Okay? So you do have a couple choices there. That says slippage again. Those jerks. Oh well. That's good. Yeah, well, let me change it. Jerks. So that's what we got to do in these. Like number 2 rather. Write the equation line that passes through the given points for all of these. So the first thing we need to do up in here is figure out what our sloppage actually is. And I like good old rainbow method. So from 4 to 3 I would go down 1. And from 0 to -1 I would go to the left 1. -1 divided by -1 is 1. That's my sloppage. So I got a y equals my sloppage, which is a 1, times x. And actually for this one they gave us the y-intercept. So we found it. It's a positive 4. There's our equation. So number 3, we kind of look at this one and think we have the y-intercept on at these. We don't. That right there is the x-intercept because the y value is 0, not the x value. So I will use a rainbow method on these because it's so much fun. So from 9 to 0, you would go up 9er. And from -5 to -2, you'd go to the right 3. So 9 divided by 3 is 3. That gives us our sloppage, m equals 3. So now, yes, down 9 means that's negative. So -3. Sloppage is -3. That's very good. Thank you. Well, from up in here, you guys want to use point-slope form or slope-intercept form to find the y-intercept? Slope-intercept. All right. So sloppage-intercept, y equals m, which in this case is -3, x plus a b. And we have 2 points to use from these. Which point do you guys want to use? Because the choice is yours at Chuckarama. Cougar, which one? Bam, let's use this one. So x is -2, and the y is 0. So we'll solve with these. -3 times -2 is 6. So I got 0 equals 6 plus a b. To solve for b, we just need to subtract 6 on both sides. It's a 6. So I got -6 equals my b value. And now I got a y equals my sloppage, -3 times my x. And then plus that b value, which is a -6. Bam, there it is. We found the equation. Let's find us some sloppage. So from 0 to -6, hopefully I can do this one right, I would go down 6. And 0 to 3, I would go to the right 3. So my sloppage is -6 divided by 3, which is a -2. Alright, we did the last one using slope-intercept form. So those of you that like it can still use it. I'm just going to use point-slope form on this one. So y equals my sloppage, which is -2, times an x minus my x value. Which point do you guys want to use?
0, 0.
0, 0. Let's use this one. The x value is 0. And then plus my y value, which is 0. Oh, very nice. So when we distribute this -2 in there, we get a y equals a -2x. -2 times 0 is 0. Plus a 0. And we can see right here that we can just get rid of this garbage. Now, some of you noticed that this 0, 0 was, in fact, the y-intercept. because the x value is 0, and you would have just put plus 0 right there, maybe. Some of you guys would have just erased it. It doesn't matter. In any case, this is our answer. Alright, so let's go back and use 3, -6 just to confirm that it does work. And the reason it should work is because this is a linear equation, meaning that the y-intercept is the same no matter which point we use. So the x value I got is 3. The y value is a -6, so I'm going to make that a -6 up in here. Now when I multiply that -2, I get -2 times -3, which is a +6 right here. But then I've got the -6. So the 6 minus 6 cancel out, and I get y equals my sloppage, -2 times x. Of course, again, you could put plus 0 if you really wanted to, but why work harder than we need to? Good luck.
Okay. So, first thing we do is we find the sloppage, and that would be this arrow right here is a positive 1, and this right here is a positive 2. So that's 1/2, can't simplify down. So m equals -2, 1/2, so 1/2. Next, I'm going to use this ordered pair right here, and that would change into 2 equals 1/2 times 2 plus b to find the y-intercept. So next you would simplify these two, so you would get 2 equals 1 plus b minus 1 minus 1, and you get 1. 1 is, what in the world?
There we go.
Oh, thank you. 1 is equal to b. So our equation y equals 1/2 x plus 1.
Bam. Nailed it. Excellent work.
What form did you use?
Alright, let's find our sloppage first, right? It's important to find good old sloppage. So, our m is going to be some kind of fraction. From 2 to -6, I would go down 8ths. And then from 1 to 1, I would go to the right 0, exact.
You can't divide by 0.
And we find that the sloppage is
Undefined.
undefined.
So we don't have to go any farther, right?
No, we do. Definitely do.
Oh.
The equation just can't be written in sloppage intercept form, that's all.
Isn't it just x equals what?
Yes.
Yay.
X equals a 1.
Yeah, right?
Because on the graph, here's what it would look like, right? We got an undefined sloppage. That means it's going to be up and down, but where? Well, we got a point at 1, 2, which would be about right here. And 1 -6 would be about right here. We can see it creates a vertical line.
Oh, yeah, so that would make sense by the y thought.
This one is just as nice as the last one. Again, we'll find our sloppage the same way. I like using rainbow method because of all the rainbows. Well, from 4 to 4, we would add exactly 0. Right? Would add 0 to 4 to get to 4. So what would we add to -2 to get to 0? 2. So I got 0/2, and I find that 0 divided by 2 is 0. Well, that's a doable one. You guys like the slope-intercept form, well, so let's do it that way.
Wait, so then we just...
Y equals my sloppage.
Because 0/4
0
is
times
already
x.
a y-intercept, right?
Wait, so my...
Oh, yeah, I guess it did. I should have noticed that, but I did not. Yep, it did give us the y-intercept 0/4.
Visual here.
So let's get rid of this garbage.
So the y-intercept and the y-value is same throughout the entire line.
That is
So
correct.
Is it just y equals 4?
Yep, y equals 4 would be the equation. If you wanted to write 0x plus 4, I'm actually okay with that. But some of you guys noticed that the y value did not change, which means the y is just 4 all the time. It doesn't matter what x is.
The x value.
X is changing everywhere. Y is not.
So the x value is simpler.
It does. But on the... Well, there's the full page. First page. Write an equation for a line from the given information in each table. Alright, number 8 then. Alright, so our objective, once again, is to write this in sloppage-intercept form. So first thing we need is good old sloppage. And from the tables, we learned that in the first lesson, I believe it was. Or we learned it in the last unit, actually. We just need to choose 2 points to use to find good old sloppage. So which 2 do you guys want to use? I heard 3, 8, and
4, 9.
4, 9. That's okay. So our sloppage, M, I need to find how far it goes up or down. That's the change in the whys. So from 8 to 9, I would go up 1. That's my numerator. And the X, my horizontal change, from 3 to 4 goes to the right 1. So I get 1 over 1, which is simplified 1. Alright, well, let's use point slope form. So that gives us a y equals the sloppage, which is 1, times x minus, which coordinate pair do you guys want to use? Ordered pair. I heard 6, 11. That'll do it. So my x value is 6. Again, it doesn't matter which point you use because it's already linear. And then the y value is a positive 11 up and count. So to solve this, I'll distribute a 1. 1 times x is just a 1x. 1 times negative 6 is negative 6. We got that plus 11. So I got y equals 1x minus 6 plus 11. And to finish this off, I get y equals 1x. And we got negative 6 plus 11, which is positive 5. So what's different about this table than from the other 6 problems we just barely did? There's just one minor difference, really, right? In the first page, they only gave us 2 points to use, right? Now they've given us 4 points in this specific table, and it just gives us more options in terms of points that we can use when we're plugging this into point slope form or even slope intercept form to find the y-intercept. Alright, let's find our sloppage. Once again, it's crucial that we find a sloppage first. Make it a fraction. So which 2 points do you guys want to use in this one?
2 and 3 and 6 and 9.
2 and 3, and good old 6 and 9er. So from 3 to 9er, looks like we would go up by 6, so that's our numerator. And then we would go to the right 4, and we can simplify these by dividing both of these by 2, it appears. And that would give us a sloppage of 3/2. It's always nice to have fractions because we can use calculators. Now, last time we used point slope form, so this time let's use a slope intercept form. We got a y equals my sloppage, 3/2 x, and then we got plus a b. Of course, we're solving for b. So, which ordered pair do you guys want to use?
4 and 6.
4 and 6. Alright, so my x value is 4. And my y value is a 6. Now when I solve these, 3/2 times 4, should get 6 out of that. Now we got 6 equals 6 plus a b. And to solve with these, of course, we would subtract 6 from both sides. And we get 0 equals b. So the y-intercept is 0, 0. And the equation y equals m, which we found the sloppage, is 3/2. X, and then our y-intercept was plus 0. Just most people don't write it in there. Because it is the identity property of addition. That'll do. I do want to point this out just because it's important for you guys to see. The sloppage, like remember guys from last unit, if you took the y value and divided it by the x, if it's the same for all the ordered pairs, then it's automatically proportional, which means your y-intercept is 0, 0. So on this one, we would have 3 over 2. Does that equal 6 over 4? Sure. Does that equal 9 over 6? Sure. Does that equal 12 over 8? Bam. Nailed it. All of these are equivalent. Therefore, this table is proportional and has a y-intercept of 0, 0. And we could write that plus 0 in there. There we go. Let's find good old sloppage again. So let's find good old sloppage. Our change in the y is, well, I added exactly 0. So my numerator for sloppage is 0. So from negative 12 to negative 10 would have added 2. So I got 0 over 2, which divides into 0. Sloppage is 0. That's pretty convenient because we can figure out the rest of this garbage. Y equals 0 times x plus a b. And we can use any of the points. I'm going to use the bottom one. Down right account. Yeah, I know some of you guys have the answer, right? But we need to show it the old-fashioned way because not everyone figures this out right away, and that's okay. So x is negative 6, y is negative 1, and 0 times negative 6 is 0. So I got negative 1 equals 0 plus a b. So this just simplifies to be negative 1 equals b. Well, now I got my slope-intercept form. Y equals sloppage is 0 times x plus the b value, which is negative 1. Of course, this simplifies to be y equals negative 1. So we got to write the equation for this line as given. And this one isn't too bad because we can see exactly where the y-intercept is. Right here. So that is 0, negative 4. All we must do is find sloppage. So let's take a look at that. They gave us 2 points to use even. See that? This point and then this one. So if I make my right triangle like these, looks like I go down 5 and then to the right 5. So my sloppage is down 5 to the right 5, which simplifies into negative 1. So my equation, y equals my slop. I'm supposed to be negative 1, by the way. Negative 1x. And then my y-intercept was negative 4. 0, negative 4. Done. Same idea for this one. The only problem is the y-intercept cannot be identified as an exact point because it's not on any of the grid corners. So we will have to figure that out using either point-slope form or slope-intercept form. The choice is ours, of course. It gave us 2 points again to use. That's extremely convenient for the slop. So my sloppage looks like I go down 2 and then to the right 3. So my sloppage is negative 2/3. You guys want to use point-slope form or slope-intercept form? Slope-intercept. Very good. So y equals m, which is negative 2/3 x, and then plus a b. So we had 2 points right up in here. We got this point 1, 1, or this point negative 2, 3. So which point do you guys want to use? There were more, of course, but just looking at these two. I'm going to use 1, 1 because that should be... No. Yeah. Dang it. Well, it looks like I will. Because the y-intercept is going to be some kind of fraction anyway. So 1, 1 should work. So I replace the x with 1 and the y with 1. And I just solve. So negative 2/3 times 1 is negative 2/3 plus a b. This needs to equal 1, so to solve with these, I would add 2/3 to both sides. 1 plus 2/3. That's really just 3/3 plus 2/3. That would give us 5/3 equals a b. This cancels out. Well, that's extremely convenient. Now we got the y-intercept and the sloppage. So I got y equals negative 2/3 x plus the y-intercept, which was a positive 5/3. All right, well, first, this is the whole page with all the work that we've done. So, just for the video, so if you guys wanted to just pause it and look at it. Find, fix, and justify. These are good for you guys because usually these involve some kind of extremely common mistake, which we don't want you guys to make on the test. So, just be aware. I know that they should check their own work, right? But, again, we don't want you to make the same mistake. So let's take a gander at these. We got these points, -1, -2, and 1, 1. Those are the points that were given on the graph. Right here. And then we got the equation for sloppage, -2 minus the 1. That's -3, -1 minus the 1, which is -2. That's okay. That simplifies into 3/2. So they got the sloppage correct. What the heck is going on up in here? Then we got 3/2 times 1 is just 3/2 equals 1. So b equals 3/2. Garbage! No! They can't do that. At this point, what we would have to do, what you'd have to do, is subtract 3/2 from both sides. We just did an example like that, by the way. So, subtracting 3/2 from both sides gives us a -1/2 equals the b. Bam. So we can't just say that 3/2 is equal to b at this point. No. That is garbage. We had to figure it out. Y equals the sloppage, which was a 3/2, times x, and the b was a -1/2. That would be the correct equation for the line. In any case, we're just going to write the equation of a line in sloppage intercept form when you're given 2 points on the line. Here we go. Well, for the bell work, and this is great about this problem, is that we just saw how to find the sloppage from 2 points. So that's the first thing you would want to do, is find the good old sloppage. Or slippage. From the 2 points.
No, you're supposed to write old, not old.
No, they're old. Not old.
Old, like the old slippage.
Yeah, OLE. No, I know what you're talking about. No, this is old because it's a very archaic concept. From the 2 points. Find the good old slippage from the 2 points. Then you either find the y-intercept or simplify point sloppage. Oh, I got it that time.
We have a slippage word, but not sloppage.
Yeah. The great thing about this is that these are essentially the instructions that we will be using to solve all the problems on this classwork and the homework as well. So, number 2. We will be finding the equation line that passes through the points for 2 through 7. So, for example, we got from 4 to 3. To find my good old sloppage, I would have gone down 1. And then from 0 to 1, I would have gone to the left 1. So, simplifying at these gives me a sloppage of 1. And in the equation, y equals mx plus b, we just found m, which is a 1x. And we need to find the y-intercept. Bam, I just found it. It's right there. The x value is 0, while the y value is a positive 4.
Wait, isn't it
So there was no need for point slope form on this, or to use slope intercept form to find the y-intercept. It was given. Now here's the problem with 3 is a lot of people look at that negative 2, 0 and say, oh, I found the y-intercept. No, you did not. You did not find the y-intercept. What you found was actually the x-intercept. So it is unusable in terms of finding the y-intercept. I mean, unless you're going to use point slope form or slope intercept form. So let us solve for good old sloppage. So from 9 to 0, I would go down 9. That's my numerator. And then from negative 5 to 2, I would go to the right 3. So I got negative 9 over 3, which simplify into negative 3.
Or positive.
Now for second period today, we used slope-intercept form to solve this one. So for you guys, we will be using point-slope form. So we got the good old sloppage, which is negative 3. We got an x minus. I'm going to use negative 5 9er, because we used negative 2 0 in the other class, which is on the same video.
But isn't it so easy?
So on these, my x value is negative 5. And then we got plus old 9er. That's my y value. Hopefully you guys remember this point slope form stuff. If not, you're going to have to watch the previous video. Now, well, actually I'm going to make that a plus right account.
I watch the videos of
It's minus a negative 5. Alright, in any case, now I'm going to distribute this negative 3. So I got y equals a negative 3x minus a 15 plus old 9er. And from here, all we're going to do is combine like a term. So I got y equals negative 3x. Negative 15 plus old 9er. Bam, negative 6. That is what we got in the other class as well. So we can see it doesn't matter which point we use or which method. It is always the same. Okay. So I'm going to find good old sloppage, m. And if we went from 0 to negative 6, you'd go down 6. That's my numerator. And then from 0 to 3, you'd go to the right 3. So negative 6 divided by 3 is a negative 2. We found good old sloppage. Next, we'll need to find the y-intercept. Bam! Once again, I have found it. Because the x value is 0, the y value that corresponds with it is the y-intercept. So I can write the equation out already. Y equals my sloppage, negative 2 times the x. And we can see this y value right here is 0. So as it turns out, if you wanted to write it like this, I'm okay with it. Some people just prefer to write this as y equals negative 2x. Because it's the identity property of addition. Both of these are good for me. So it's really up to you. Either one of these will work.
Does it just say like the Dow?
Now for the other class, we used 0, 0. And I think we used point slope form. And then we solved that. So if you didn't notice that that was the y-intercept, you didn't have to. You could still have used slope-intercept form or point slope form to simplify that. All right, number 5. Well, from right here, again for sloppage, which will be a fraction, I would go from 2 to 3, which is an increase of 1, form y-intercept right here. And then from 2 to 4, we would increase that by 2, so to the right 2. And that's my sloppage, which now cannot be simplified. So, on this one, I want to say we used slope-intercept form as well. So, point slope form. Y equals the sloppage, 1/2, and then in parentheses, x, a minus, I'll make that a minus. Which point do you guys want to use?
Let's use 2.
Sounds good. 4, 3 is great.
Yeah.
So, I got a 4 right here. And then we'll make that a plus 3.
Do you always do plus 3?
You always do plus the y value. If the y value was negative, we would make it a minus. Yeah. Good question. All right, now I will distribute the 1/2. So I got a y equals a 1/2 of x. Minus 1/2 times 4, which is 2. And then I still got that plus 3 out here. All right, from here, this isn't too bad. We got y equals the sloppage, 1/2. x, and then we're just going to simplify this. Negative 2 plus 3, bam, plus 1.
Do you always subtract that?
Shouldn't it be?
That is what we must find out on this problem. So let's find good old sloppage foist, m equals. And from 2 to negative 6, we would go down 8. That's our numerator. Down 8. And then from 1 to 1 is an increase of 0. So negative 8 divided by 0. The great thing about this is the calculator will tell you what this is. M is undefined. So, since it's undefined, we know, hopefully from previous lessons, we remember this if we pay attention. Well, we can't write this in slope-intercept form at all. So it's just x equals whatever x value is, 1. See, because x is 1 right and count, no matter what the y value is. So x is just never changing, no matter what y is. If we, hopefully again, this is just for review purposes. On this one, like if I graph the point 1, 2, maybe it's right about a count. And 1, negative 6 would be right about a count. That gives me a vertical line. See, there's not even a y-intercept on this thing. That's the next question. So, right here, let's find good old sloppage. Let's give ourselves some more space. So, from 4 to 4 means it went up exactly 0. So our sloppage is 0 divided by something. Negative 2 to 0 is to the right 2. So 0 divided by 2 is 0. That's our sloppage. And right here, let's use slope-intercept form to figure this thing out. We got y equals m, which is 0, times the x value, plus a b, because we don't know what the actual y-intercept is yet, unless some of you do. And right here, we can use either one of these points to solve. I'm going to use negative 2, 4. So my x is negative 2, while my y is 4. So 0 times negative 2 is 0. And now we got 4 equals 0 plus a b. When we solve these, we get 4 equals the b value. So we see that y equals a 0x, and then plus the b, which was a 4. Of course, some of you don't want to write all that garbage because 0x is just 0. It cancels itself out. And we find that y is 4. Again, some of you guys notice that the y value is 4 no matter what the x value is.
Is it right?
The y is never changing no matter what the x is. So it doesn't matter what the x value is. The y is always 4. No matter what.
What happens if it's
Any x value will give you a y value that's 4. No matter what it looks like. It could be a decimal value. And the y value will be 4. Even if it's negative. If it's a negative, it's still 4. Even if it's a decimal that's negative. Let's say that it was irrational.
Is that correct?
Then it still doesn't matter.
0x plus 4, is that correct?
No. Because y equals 4 is also correct, so either one will work.
Oh, so
Well, there's the full page of notes there. All right, let's write the equation from the line that produced these tables. Like number 8. So there's a huge difference between what we see right here and what we the last 6 problems that we just barely did. In fact, the big difference is now they've given you lots of points to consider. Finding the sloppage of, and then using in point-slope form or slope-intercept form. So it just means we have a lot more options. It should not make the problem any more difficult. So, for example, we only need to choose 2 points from the graph to find the good old sloppage. 3, 8, and 5, 10. Sounds like a good one. So our sloppage, let's figure this out. I need to figure out the vertical change, which is my y's. From 8 to 10 is up 2, so that's my numerator. And from 3 to 5 is to the right 2. That's our denominator. When we divide these, we get 1. So we see that y equals a 1x. And Sloppage-intercept form. So that would be y equals 1x plus a b. And which point do you guys want to use to figure out the y-intercept?
611.
Sounds like a good one. 611. So I'm going to replace the x. I will replace the x with 6. And the y with 11. So when I multiply these, 1 times 6 is 6. So I got 11 equals 6 plus a b. Some of you guys would just ask yourself, what plus 6 is 11? And you would know the answer. Others of you would just solve this like a regular equation. Subtract both sides by 6. And we see that 5 equals the b. So now we can write the equation y equals m, which is 1, times the x, and then the b value was a plus of 5. Alright, number 9er. So let's find the sloppage on this table here in the top left up here. I need a little bit more space though. So we do need good old sloppage. Yep. So which 2 points do you guys want to use?
2, 3, and 4, 6.
2, 3, 4, 6. So 2 next to each other. That's a good choice. From 3 to 6, I would have added 3. That's our numerator. And from 2 to 4, I would have added 2, which is our denominator. That cannot be simplified. That's a good thing. And let's use, point slope form. Yeah, that's good. So y equals the m, which is a 3. Oh, that's not a 3. 3/2 times the x minus, which point do you guys want to use? 6 9er. Alright, so that's what point we'll use. A good old 6 for the x. And then plus the y value, which is a 9er. So, to simplify these, 3/2 times x is a 3/2 x. And then 3/2 times negative 6 is a negative 9er. And of course we got this plus 9er out of count. So if y equals this garbage, y equals 3/2 x, negative 9 plus 9er, cancel away. This is our answer. I found it. Of course, if you put the plus 0, you'd still be in good shape. All right. Negative 10, negative 1, that we can use that one. What else?
Negative 6 and negative 1.
Negative 6, negative 1. That sounds good. So from negative 1 to negative 1, on our sloppage, we got 0. From negative 10 to negative 6, that's an addition of 4. 0 divided by 4, your calculator will do this one for you. 0. So we got y equals 0x, and then plus a b. And which point should we use for finding the y-intercept? Negative 8, negative 1. So the x is negative 8. And the y is negative 1. So we can see 0 times negative 8 is 0. That's just going to cancel away. So we got b equals negative 1. So we got y equals 0x minus a 1. Or that y equals negative 1. Either way. So we got 2 graphs now, and we will find the equation for both. Let's start with the 11. So on this one right account, they did give us 2 points on the line. That was extremely generous of them, so we can figure out good old sloppage on account. Looks like I would go down 5, and then to the right 5. Down 5 to the right 5. So when I find my sloppage, I got down 5 to the right 5, which simplifies to negative 1. So in my equation, I got y equals my sloppage, negative 1, times the x, and we can see the y-intercept right here at the point 0, negative 4. So my y-intercept is negative 4. B is negative 4. There's our All right, let's find the equation for these. And again, they've given us 2 points. Let us use these 2 points. We'll go down 2 and to the right 3. It's not really over 3. We need to specify that it's going to the right, okay? Be very careful, because sometimes it would be over is in the negative direction, so be very careful. So we can see sloppage is negative 2/3. And when we find the equation, because this y-intercept radical is an unknown y value, even though we know the x is 0. So no good on that. We're going to have to use some other way to figure out the y-intercept. Let us use point slope form. Okay, that sounds like a great idea. So I got a y equals my m, which is negative 2/3, times x. We got 2 points here. This is a 1, 1. And this one is negative 2, 3. We'll use negative 2, 3. So that'd be minus negative 2, so I'm going to make that a plus 2 radical. And then the 3 plus a 3 up in count. So after I distribute the negative 2/3, I got a y equals negative 2/3 x minus 4/3. That's just 2/3 times 2. Would give me 4/3 plus 3. I'm going to give this a common denominator right now. Oh, that's not where that goes. 9/3 would be better. I'm going to change that so that it has a common denominator so I can combine my two fractions radical. So when I combine at these, I get a y equals negative 2/3 x. And when I combine this negative 4/3 plus 9/3, bam, I get a positive 5/3. Which is about what that looks like. 1.6 repeating. So there's my answer for this one. Alright, just in case you wanted to, here is all the answers for this page. Looks pretty. I like using the colors. They're very pretty. Find, fix, and justify. Jamal was asked to write an equation for the line on the graph below. Jamal worked in is shown to the right of the graph. He has made a common mistake. Very, very common. In writing the equation for the line, find Jamal's mistake and explain what he did wrong. Then write the equation for the line. We can see, radical, that he used the equation to find sloppage, which he has done correctly. The sloppage is 2/3, which we could point out on the graph, right? As up 3 to the right 2. That's fine. Then he set up slope-intercept form correctly as well. The setup, this one, checks off. Bam. What he's done wrong is radical. No good.
Wait, but why would it be a 1 equal?
Yeah, he's using the point 1, 1, this point radical. Now, what the heck happened though? Well, it looks like maybe he just moved the b over and then somehow he just replaced the 1 with the b and then got rid of that garbage is what it looks like. I don't know why he did it. I don't know why people do it. But they do it, okay? So be very careful. This would not be the answer. Again, his setup is good, though. So we need to go back. Let's get rid of this garbage. And figure out what the heck we need to do. So, it's not this. We need to subtract 3/2 from both sides. So minus 3/2 radical. 1 minus 3/2 is a negative 1/2. And then this is there. We just get the b value, which is negative 1/2. So we got y equals the sloppage, which was already found to be 3/2, times the next value, minus the b, or plus b, what the heck, 1/2. There it is.